Welcome to the Volcano Museum. It's my great pleasure to share with you a collection of volcano art and other objects related to volcanic eruptions that I've collected all over the world during my 50-year career as a volcanologist. As you probably know by now, Iceland is all made up of volcanoes. All the rocks you see in Iceland are of volcanic origin, and it keeps growing, and new material is being added to it all the time. Now, Iceland, of course, sits on the Earth's crust, and the Earth's crust underneath us here is about 30 kilometers thick. But under the crust, there's the region in the Earth that we call the mantle, and the mantle is the most important region of the Earth. It's about 80% of the volume of the Earth, the mantle. But we never see the mantle because it's always covered by the crust. Except once in a while, pieces of the mantle are thrown out by volcanoes during volcanic eruptions. And if we look in the cabinet here, we'll see this rock that's covered with black lava on the outside, but green, shiny green crystals on the inside. That is actually a piece of the Earth's mantle. And that is a piece that was thrown out by a volcano in Cameroon in West Africa, and I collected it there several years ago. And so those are very rare pieces of the Earth's mantle, and they come from a depth of about 150 kilometers down in the Earth. We know that because it contains minerals that are only formed but at very high pressure, including diamonds. All the diamonds that we find at the Earth's surface originally came out of the mantle. So that rock is also very important because it shows us how the magma or molten rock is formed that creates the volcanoes. It is formed by partial melting in the mantle. And if we look closely at that green rock, we'll see that there are little black specks in it, and those are glass. Because when it was thrown out, it was red hot, 1200 degrees centigrade or 2500 degrees Fahrenheit, and then it was chilled rapidly and the liquid inside it turned to glass. So that's how all the volcanoes originate. They all originate by material that is created in the Earth's mantle. Iceland has a short geologic history compared to other countries, but still we have rocks that are a few million years old in Iceland. Actually, the oldest rocks that we find in Iceland are 16 million years. That's geologically very young, but for us, these are old rocks. But in the rock formations in Iceland, we also find wood or lignite, like this material here. This is the beginning of the formation of coal. And this wood or this lignite is actually about 12 million years old. And it's found between the lava flows in western Iceland, in the western fjords. And the wood has been analyzed and studied, and it turns out it is sequoia, like the giant sequoia in California. So sequoia was growing in Iceland 12 million years ago. And then the climate in Iceland was like the climate in south of France or in California. It was very warm, with mean annual temperature of about 15 degrees centigrade, which is around 60 degrees Fahrenheit. So big trees were growing in Iceland at that time. And then the Ice Age came, starting about 3 million years ago, and we're still basically in the domain of the Ice Age. It ended about 10,000 years ago in Iceland. Also in this cabinet, I want to draw your attention to this long and skinny piece of paper, which is a map. It is a map that shows the Laki eruption of 1783 in Iceland, the biggest eruption that has taken place in Iceland's history and the most damaging event in Iceland's history. This eruption produced a fissure in the ground that is 25 kilometers long, and on this fissure there were over 100 craters all erupting at the same time. And it produced the biggest lava flow that has been erupting on the Earth in historical time. About 550 square kilometers of lava, a huge expanse of lava. But the main problem was the gases that came out during this eruption. A lot of gases came out of these craters, including sulfur dioxide, carbon dioxide, water vapor, sulfur, and chlorine and fluorine gases. And these gases condensed in the air and then deposited on the land and destroyed all the crops and all the fields. All the livestock, the sheep and the cattle and the horses, all were affected when they were grazing on this land, and 75% of all the livestock in Iceland died. And the eruption had a huge impact on the Icelandic population. It decreased the population by 24%. It's the biggest disaster in Iceland's history. It was a very famous event that took place during the Laki eruption in 1783. When the lava was advancing over the land, it covered many of the farms, and it was threatening this farm where there was a church. And the vicar, or the priest of this church, wrote a detailed account of this eruption, a book about it actually. But during the eruption, the lava was getting closer and closer to the church and to this farm, and it was threatening it. So here's the vicar, or the priest, and he's calling the congregation into the church, and you see the eruption in the background, and they're threatened by it. They go into the church and they pray and have a sermon, and well, miraculously the lava did not destroy that farm, and the church was saved. So it was a very important event in the history of Iceland, this particular eruption. Our museum is on the Snæfellsnes Peninsula, and at the head of the peninsula is the Snæfellsjökull volcano. It's a very famous volcano because it was featured in the first science fiction book ever written. That's The Journey to the Center of the Earth by Jules Verne in 1865. Now in this image we have Snæfellsjökull showing a very large glacier, and this is from 1845, when the glacier was much more extensive than it is today. According to the melting that's going on of the glacier now, it'll be all gone in about 30 years. Now Snæfellsjökull is an active volcano. It hasn't erupted since for about 1700 years, but it's still active, and we know that because there are earthquakes located underneath it, indicating a movement of magma. Perhaps Iceland's most famous volcano is Hekla, and we see it in this picture here. This is a picture of the Hekla eruption in 1845, and it was a big explosive eruption, and it spread ash all over this area, as you see from the black coating of all the land. Now Hekla has erupted very many times, and it is a volcano that has been very important in Iceland's history. Our oldest work of art in the museum is actually this piece here. It is from 1551, and it shows Hekla volcano erupting. It's an engraving from a book that was published in 1551, and there's an account of Hekla and the description of Iceland. So Hekla has been in history very long time, very important volcano in Europe and in Iceland. Now there's another picture above here, this long and tall picture that shows Hekla erupting in 1947. That was one of the biggest recent eruptions of Hekla. And when you look at that picture, you can see that there are at least 3 craters erupting. And that is because Hekla is shaped like a boat upside down, like an overturned boat. And when the eruption begins, the keel of the boat, or the middle of the volcano, just opens up along a long fissure that's about 4 or 5 kilometers long. And the craters erupt all along that fissure, producing, as we can see there, an eruption along the axis of the volcano. So Hekla has erupted many times, and is one of the volcanoes that we expect to erupt at any time now. Now, many of the biggest volcanoes in Iceland are covered by glaciers because they're tall mountains. For example, the Katla volcano, shown in the painting above me here, Katla volcano erupted in 1918, and it's covered by the Mýrdalsjökull glacier. It was a very large eruption, one of the largest eruptions in Iceland in the 20th century. And you can see in that painting that the volcano is blowing a hole through the glacier. A big cloud of ash and gases and steam is coming out of the volcano, and it's what we call a subglacial eruption. These are the biggest problem in Iceland's volcanoes, these subglacial eruptions, because they melt the ice and cause tremendous flooding. So the main danger of many of these Icelandic volcanoes is related to the ice and to the glaciers and the melting and the flooding. Katla eruption in 1918 caused a huge amount of ash fallout and floods, but extended out the south coast of Iceland temporarily for about 4 kilometers. That's how much material was added to Iceland at that time. Now on the other side here above me, we have another subglacial eruption, and that is Grímsvötn volcano in southern Iceland, which erupted, as shown here, erupting in 1934. And that was a big explosive eruption, and Grímsvötn has erupted many, many times since, and it is actually Iceland's most active volcano. It erupted last in 2011. So these are the subglacial volcanoes that we're especially worried about and that are likely to cause major problems in the future. One of my favorite works in the museum is actually this work here by famous American artist Andy Warhol. This is an original Andy Warhol, and we're very proud of it. And it shows an eruption of Vesuvius volcano in Italy. Now, Vesuvius is a very famous volcano, very important one, has a long history. But Andy Warhol was there in 1985, and he fell in love with the volcano and did a series of paintings or artworks on the volcano. Now, he didn't see it erupting, but he had seen the Mount St. Helens eruption in 1980 in the United States. And so he superimposed the Mount St. Helens eruption on top of Vesuvius and created this beautiful work. That's the only landscape that Andy Warhol did, was of Vesuvius erupting. Vesuvius volcano has been featured very often in art, and various illustrations of it have appeared throughout history. This is a particularly interesting piece that shows Vesuvius, and this is from 1638. It's an engraving done by Athanasius Kircher, who was a Jesuit priest who was fascinated with volcanoes and wrote a very famous book called Mundus Subterraneus, or the Subterranean World, where he described many volcanoes, including Vesuvius. And he featured this illustration of Vesuvius, but in it he did a revolutionary thing. He made a section, he cut away a part of the volcano to show us what's inside, or show us what he thought was inside. And he thought it was a burning mountain. At that time, and all the way from the 1st century to the 18th century, people thought that volcanoes were burning mountains. They thought that there was a fire inside with sulfur and maybe fossil wood or coal or something that could burn, and that the volcano was essentially a place of burning. Now, of course, we know that that is not correct, because we know that volcanoes are places where molten rock or magma comes out of the earth. There's no burning, there's no oxygen. It is simply very, very hot magma coming out at about 1200 degrees centigrade or 2500 degrees Fahrenheit. But Athanasius Kircher was so fascinated by making a section, and he's the first one to make a section of the entire earth that we see in this work of art here by him, with a big central fire in the middle of the earth, and then very small fires underneath each of the volcanoes. So that's how science makes progress. People come up with new ideas, and then they're discarded, and a better idea comes along. The most famous eruption of Vesuvius was actually in 79 AD, in Roman time. And then the emperor of Rome was Titus Emperor. And that, shortly after he came to power, an eruption broke out in Vesuvius. And that was a very large explosive eruption that immediately led to the destruction of the cities of Pompeii with 25,000 people, and Herculaneum with about 4,500 people. And in our collection we have various objects and items that are related to this tremendous eruption. We have, for example, objects from Pompeii and maps and diagrams showing Vesuvius, and also photographs of casts of victims of Pompeii. What happened is this was a very large explosive eruption, and it produced what we know as pyroclastic flow. Pyroclastic flow is a mixture of ash and pumice and gases, and this is a flow that comes down the flank of the volcano at a very high speed, maybe 100 kilometers per hour, and a very high temperature, 200 to 400 degrees centigrade. And pyroclastic flow is like an avalanche, except that it's a hot avalanche, very destructive. So it destroyed Pompeii and Herculaneum instantly, and buried all its people. One of the volcanoes of Italy was actually born in the year 1831. And that happened when a British battleship was sailing along in the Mediterranean. All of a sudden they see a new island forming in front of their eyes. They sail along and they come to this volcano erupting and a new island coming out of the ocean, explosions and ash accumulating, building up the island. They make a landing on the island and they put the British flag on it and they claim it for the King of England, and they gave it the name Graham Island and made this drawing, beautiful drawing. And then the Italians came and they did this work of art here, and they named it Ferdinandia after the King of Naples, and they put the Italian flag on it. And then the French came, they named it Julia, claimed it for France. And then so it was becoming a contested issue. Everybody wanted this island because it had a major strategic importance in the Mediterranean. But then the eruption stopped and the island disappeared. It was broken down by the sea waves and there was no longer any issue or problems about that. So this is an example of the formation of a new island, which occurs from time to time in Earth history. The biggest eruption that we know of in Europe's history was not in Iceland, it was not in Italy, but it was on Santorini in Greece. Now, Santorini is an island in south of Greece in the Aegean Sea, and in the Bronze Age, about 1627 BC, a huge eruption broke out on the island of Santorini. Here we have a map of Santorini that is from 1595 and shows that it's a circular island with a large caldera or a huge hole in the middle that's about 10 kilometers in diameter. It's an enormous volcano. And this explosive eruption of Santorini in the Bronze Age created a huge pyroclastic flows that extended over the ocean, and it produced tsunami or tidal waves that reached all the way to Crete. Now we know that on Crete, on the island of Crete, which is about 85 kilometers south of Santorini, the tsunamis or tidal waves were up to 10 meters above normal sea level. So it caused total destruction. At the time there was the Minoan civilization active in Crete and in the Aegean Islands around Santorini. The Minoans they came after the classical Egyptian civilization, and they preceded the classical Greek civilization. So they were a very important link. But the Minoans went into a decline and almost disappeared as a result of this huge eruption of Santorini. So it is a very large volcano, and the eruption erupted about 60 cubic kilometers of magma. We measure the size of a volcanic eruption in cubic kilometers. Now, of course, 1 cubic kilometer is a kilometer on edge. It's a very large volume of material. Think about 60 of those coming out of a single eruption. So that is one of the largest eruptions in history, Santorini eruption, or we call it the Minoan eruption, in memory of the civilization that was lost. Now here we have various objects, remains from the Minoans, as well as pumices from this great eruption. Pyroclastic flows are one of the most important products of explosive volcanic eruptions. All of the biggest eruptions on the Earth produce pyroclastic flows, all of the big ones. And here's the only painting we have of a pyroclastic flow. It's not often that people witness them and survive, and it's the only one case where we know that somebody has actually painted one and got away with it. This is from an eruption that took place in Indonesia in 1982. And a few years later, I was driving along on Java, and I saw this man standing by the road holding up paintings, and I bought this piece from him, and he was the artist. And he had been witness to and painted the eruption of Galunggung in Indonesia in 1982. And here we see the pyroclastic flow coming down the valley. It's a glowing hot cloud of ash and pumice moving at a very high speed down the valley. And in the foreground we see the deposit of a previous pyroclastic flow. We see the yellow ash and smoke and steam coming out where trees are burning that have been trapped in the pyroclastic flow. So these pyroclastic flows are moving at maybe more than 100 kilometers per hour, and they're hot enough to carbonize wood and destroy everything in their path. And then they lay down a carpet of ash that is several meters thick and bury everything. So they're the most destructive part of big explosive volcanic eruptions, and most of the material produced by explosive eruptions actually is deposited as pyroclastic flows. This eruption actually is very famous, not because of the pyroclastic flows, but because of the fact that this is the first eruption that occurs on the Earth which had a big impact on aviation. 1982, there was a Boeing 747 jumbo jet flying from Malaysia to Australia, and they flew right over Java. They were up at 30,000 feet. Everybody's happy and having the cocktails up there. And then all of a sudden they fly into this ash cloud. Although they were 150 kilometers away from the volcano, they flew into a thick ash cloud. And immediately all 4 engines of the aircraft were shut down by the ash, and it started to drop like a lead balloon towards the ocean. They tried to start the engines again and again, nothing worked. But then finally, just before they were reaching the sea level, they managed to start one engine and then pull out and make an emergency landing in Java, and everybody survived, but the plane was destroyed. Of course, the ash had been sucked into the jet engines, and then the ash melts and forms a liquid magma layer inside the jet engines. It chokes the fuel intakes and the air intakes, and the engines shut down. But then, of course, they're at 30,000 feet, where the temperature is minus 60 degrees centigrade, very cold, so the magma freezes to glass, and then it breaks up and it falls out, and they were able to restart some of the engines. So we have learned a lot from that terrible incident about the potential impact of volcanic eruptions on aviation from the Galunggung eruption of 1982. Now, if you're really interested in volcanoes, you really should go to Indonesia, because Indonesia has 150 active volcanoes, and there's an eruption there every day somewhere, guaranteed. Now, Indonesia also has the volcano that produced the biggest eruption in history, and that is a volcano called Tambora. Tambora. It's on an island of Sumbawa. Here's a map of Tambora. It's a very large volcano, and today it has a caldera that is about 9 kilometers in diameter and 1,500 meters deep. It's the deepest caldera on the Earth. And that caldera was entirely formed during the Tambora eruption of 1815, which was the biggest eruption on the Earth in historical time. It produced 100 cubic kilometers of magma. Tambora started to erupt in April, but soon there were big pyroclastic flows coming from the volcano. And these pyroclastic flows inundated the entire land area in the island, and led to a death of 123,000 people in Indonesia, the biggest death toll we know from any volcanic eruption. Now, that was not enough, because the volcano also produced a stratospheric aerosol. That is, when the volcano of this type erupts, it sends a tremendous amount of gases, mostly sulfur dioxide gases, up into the atmosphere. And these gases form an aerosol layer in the stratosphere. And that layer backscatters solar radiation away from the Earth. So it causes cooling at the Earth's surface. So it caused what is known as a year without a summer. Globally, a cooling year without a summer of 1816, the year following the eruption, was the coldest on record. So volcanoes can really have an impact on climate, as we've learned from the great Tambora eruption. On Tambora, there was a kingdom of Tambora, and there was a big town there, maybe with about 5,000 or 10,000 people. And that town was totally lost, and everyone was killed in that town. The town, I started to work in that area in 1989, but it wasn't until 2004 that I found the town. I found it 25 kilometers from the volcano, but even there it was buried under 4 meters of ash. And in the town, everything is buried, everything is carbonized by the high temperature of the pyroclastic flows, but these are some objects that have been recovered from excavations in the town of Tambora. Just like a Pompeii. In fact, it's the Pompeii of the Orient, if you like. Another very famous volcano in Indonesia is Krakatau volcano. And on the lower shelves here, we address the Krakatau volcano, and it erupted in 1883. Another big explosive eruption, an explosion that was actually heard around the Earth. It was recorded on the other side of the Earth, the sound waves from the explosion. We have pumices and various objects related to Krakatau here, and also images that show the volcanic island before the eruption and after the eruption. So Krakatau became very famous, although it was only 18 cubic kilometers compared to 100 cubic kilometers in Tambora. But it became so famous because immediately when it was erupting, information or news of it were sent around the world because of the newly installed telegraph system globally. This is a piece of sulfur actually. It looks like an icicle, but it's actually composed of sulfur, this yellow object. It's from a volcano in Indonesia, Ijen volcano. And it is here to remind us of the great importance of sulfur from volcanic activity. Volcanoes don't just produce lava or ash or pyroclastic flows, they also produce sulfur. And the sulfur can be very harmful because we learned that, for example, in connection with the likely eruption in Iceland in 1783, that the sulfur gases caused a famine in Iceland and huge loss of livestock. We also learned from the Tambora eruption in Indonesia in 1815 that the sulfur produces an aerosol in the stratosphere that can cause climate change and massive cooling at the Earth's surface. So sulfur is one of the important byproducts, if you like, of volcanic eruptions that we have to realize that can cause us problems. Well, welcome to the rock table. But on this table we have samples of all of the most important rocks in Iceland. Now, of course, by far the most important one is the basalt. This is an example of a basalt lava. This is the lava that berserks that is just outside the town. It's about 3,800-year-old lava. And of course the basalt lava is a product of magma or molten rock that comes out from the Earth's mantle. And that creates about 80% of all the rocks in Iceland, basalt. Now basalt sometimes stops inside the Earth, and then it doesn't erupt, but it stays there, and then it gradually cools, the magma cools, and then it has time to form big crystals, and then it forms the rock we call gabbro. So that's the same chemistry as the basalt, but it has taken a long time to crystallize deep inside the Earth. Another important rock in Iceland is rhyolite. That's this light-colored rock. Rhyolite is also erupts also as a lava, like this. But it contains a lot of silica, about 75% silica, and because of that it is light in color. Whereas basalt is rich in iron and lower in silica. Rhyolite lava flow flows like this, but the surface of the lava cools very quickly, and sometimes it forms glass or obsidian, which is this material here. So obsidian is the same chemistry, it's the same magma as rhyolite. Obsidian is very rapid cooling to form glass, and then slower cooling in the interior of the lava to produce the rhyolite. Now if the rhyolite magma stops inside the Earth, it again cools very slowly and crystallizes and forms big crystals, and it forms granite or granophyre, which are these rocks here. Now there's a third magma type that's very common in Iceland, that is andesite, this rock here, and it's named after the Andes Mountains in South America. You see here on the wall behind me many paintings from South and Central America of typical volcanoes there. They're all composed of andesite. Which also occurs in Hekla volcano in Iceland, and as well in Eyjafjallajökull. For example, the Eyjafjallajökull eruption in Iceland in 2010 threw out this lava bomb here of andesite. So we have lots of andesite too. Now these rocks here, which are red and green, are not really volcanic, but they're produced by hydrothermal activity. Now we know that the crust in Iceland has lots of fissures, like this table here, and water goes down the fissures, and then it goes down 1 or 2 kilometers, and it comes in contact with very hot rocks. And there the water is heated, and it expands and starts to rise up the fissures again, but it carries with it a lot of chemicals, especially sulfur, because It carries with it a lot of chemicals, especially silicon, because silica is the main ingredient in all of these rocks. So the liquid or the fluid, the hydrothermal fluid is coming up the fissures, and when it gets closer to the surface, it loses the temperature and precipitates out the silica and gradually seals the fissures like we see in this rock here. And we call these rocks jasper. The red ones and the green ones. The red color is because there's just a trace of iron in the material, in the jasper. And if the iron is oxidized, it is red, and if it's reduced, it turns green, like that. This rock here is a basaltic tuff, also known as hyoiclastite or Moberg in Icelandic. It's not a very pretty rock, but it's very important in Iceland. It is the type of rock that is produced by eruptions underneath the glaciers. Now, when the eruptions take place under the glaciers, the magma comes in contact with the meltwater and with the ice, and there's steam explosions. And these steam explosions tear up the magma. And then more water can get at the magma, there's more explosions, so there's a chain reaction, a series of steam explosions that tear up the magma and make volcanic ash. And the ash falls to the ground and then hardens to form this rock in a very short time. So this type of tuff is very, very common in Iceland and builds up the mountains that are so characteristic of the regions where there was volcanic activity during the Ice Age. They are very irregularly shaped mountains that are very easy to pick out in the landscape. Another rock that is of interest for us is this one here, and these two. Now this is a rock type called anorthosite. Now, anorthosite is a very rare rock on the earth. This anorthosite occurs on the island of Hrapsey, which is just outside the harbor here in the Stykkishólmur. But this rock is very common on the moon. This is, when we look at the moon, you know that the moon's surface has light gray areas and black or dark gray areas. The black areas are composed of basalt. The light gray areas of the moon are composed of this rock anorthosite. It makes for a beautiful rock when polished, as we see here. But when we look at it closely, we see that this rock is composed of only one mineral type. All the same crystals, type of crystals. And these are crystals of plagioclase. And plagioclase is the main mineral that crystallizes in the basaltic magma. So this rock was formed when there was a big magma reservoir underneath the island of Hrapsey. And then the basaltic magma was cooling, and then crystals of plagioclase started to form. And they're less dense than the magma, so they float up and they make like a cream on top of the milk, a layer on top of the magma reservoir that solidifies to produce this rock. This is a stained glass window. It's a very old stained glass window, and it's from a synagogue that was in New York. The synagogue was torn down, and I got the window. It's not unusual to have a volcanic eruption image in a synagogue, and that relates to Mount Sinai. Now, when Moses goes on the mountain, according to the Old Testament or the Torah of the Jews, then the mountain is described as having a big black cloud over it and throwing explosions and throwing out rocks, and the people are very afraid of it and move away from it. And so in the synagogues, this is in memory of Mount Sinai erupting. Now, Sigmund Freud has written two very interesting articles about this phenomenon, and he claimed that his idea was that the original god of Moses was actually a fire god, and the fire came from the volcanoes. So this has a very strong biblical or Torah connections, and so does this painting here. This painting is of Mount Ararat in Armenia. And Mount Ararat, of course, is the mountain where, according to the legend, Noah's Ark stranded at the end of the deluge. And so the big mountain we see here is Mount Ararat. This is an extinct volcano, but right next to it is Little Ararat, which is an active volcano and last erupted in 1840. So both of these images then have strong biblical connections. In 1943, there was an incredible eruption in Mexico. A new volcano appeared out of the ground, and it was called Paricutin. This farmer was plowing his field, And he looked back and he saw that there was a crack in the earth behind him, and there was some steam coming out and smoke. And then soon enough there was an eruption, and then a year later there was a mountain, a new mountain, 400 meters high, where the field had stood, and the lava and the ash was covering his village, and only the church tower stood out. So this was the creation of Paricutin. Many Mexican artists rushed to the scene to study it and to look at it, and amongst them was a very famous Mexican artist, Siqueiros. Siqueiros was one of the main artists in Mexico, and we have here this painting by Siqueiros that shows Paricutin. But he had this new technique. He took a piece of wood and then he let the paint drip on it and got this image. And with him was his American assistant who learned this technique from him, and that was Jackson Pollock, a very famous, who became a very famous American artist. Now, South and Central America are some of the most volcanically active parts of the Earth, because that's a region where two plates meet. We have one plate being thrust underneath another plate. The Pacific plate is going underneath Central and South America and causing volcanism at the surface. Now, these are images from South and Central America. Three pictures here are from Nicaragua, and they're done in the style of the naivist painting. These are painted by the regular people and sold in the market, and they're very colorful. And also we have these two paintings from Ecuador of Tungurahua volcano, shown in this large painting and this large painting here. The Tungurahua volcano has been erupting since 1994 pretty frequently, and it's right on top of the city of Baños, a large town. So the population in Baños is particularly worried that there will be pyroclastic flows coming into the city from Tungurahua eruptions, but so far they've escaped. Well, volcanic glass, or obsidian, is actually a very useful material, and was very important for the people on the Earth in the Stone Age. Now, the Stone Age people collected obsidian and made tools out of obsidian. And here we have 7 tools of obsidian, and these are from the island of Milos, from the Stone Age, and they are made by people of Milos because on Milos, which is an island in the Aegean Sea, south of Greece, there is a lot of obsidian that they fashioned into tools. We also see an arrowhead from the Rocky Mountains, from the American Indian culture in the Rocky Mountains over here, of obsidian, reminding us how useful obsidian was for early man. But volcanic glass is very common, but there's another type of glass that is found on the Earth that is not made by volcanoes, but by meteorite impacts. Now, meteorites can be huge. They can be 10 kilometers in diameter or more. And meteorites, when they're traveling, they're moving at about 40 to 50 kilometers per second. 40 to 50 kilometers per second. They're moving at extremely high speed, and then they strike the Earth, and the energy of the impact melts the Earth's crust. And that molten crust is thrown out into space, and then it rains down like pearls of glass back to the Earth. And we see some of these pearls of glass in this case here, these black spherules that we have there that are known as tektites. So tektites are a documentation or evidence of big meteorite impacts on the Earth. Now, in the circular tray over here, the light gray tray, we have very small tektites, and they are the oldest glass on the Earth. They're 65 million years old. And those tektites were produced when a very large meteorite struck the Earth, actually in the Yucatan Peninsula of Mexico, 65 million years ago. And that impact caused a major extinction all around the Earth. About 85% of all life forms on the Earth became extinct, including the famous dinosaurs. So we have here the oldest glass on the Earth, and I made this discovery in 1980 when I found this glass on the island of Haiti in the Caribbean. And it is the most important, scientifically the most important glass or material that we have in our collection, reminding us of the tremendous power of meteorites, and that they can also make liquid or magma and turns into glass, just like volcanoes can. One of the most interesting volcanic countries on the Earth is actually Japan. And in Japan there are very many active volcanoes. One of the most famous ones, of course, is Mount Fuji. On the bottom shelf here in the cabinet we have many porcelain plates showing Fuji, which is the most important mountain in Japan, both in history and culture and religion, and its worship. Fuji has not erupted since 1707, but it's an active volcano. It will erupt again. Now, many Japanese artists have featured Fuji and the other Japanese volcanoes in their art. The most famous artist in Japan is Hokusai, and here we have an original of Hokusai, the boy with the flute in front of Mount Fuji. And he was active in the end of the 18th century and in the early to mid 19th century. Hokusai also did this very famous picture here of Fuji. This is a copy, but our boy with the flute is an original of Hokusai. Many other pictures of Japan are shown here, of Japanese volcanoes, and one of the more interesting also is Asama. Asama volcano erupted in 1783 in Japan, at the same time as Iceland's biggest eruption took place. And Asama eruption in 1783 also caused the biggest famine in Japan, just at the same time as when Iceland was experiencing its worst disaster. A very famous eruption took place in Iceland in the year 2010. That was the eruption of Eldfjallasafn volcano in southern Iceland. It actually started not from the summit of the volcano, but rather on the flank of the volcano, and that eruption produced a lava flow. So for the first couple of weeks there was just lava coming out of the volcano, and but then activity shifted to the summit of the volcano, and an explosive activity began in the summit, producing quite a bit of ash. It was a small eruption, but the ash in the atmosphere led to closure of aviation across the Atlantic or North Atlantic Ocean for a week, causing tremendous impact on aviation and economy and travel throughout North America and Europe. Nevertheless, the ash eruption was very low. It was only about 5 kilometers that the ash went up into the atmosphere, but the reaction of the authorities in Europe, Eurocontrol, was to shut down aviation. It was an overreaction. It was an unnecessary man-made disaster. Iceland Air wasn't scheduled 85% of the time during the entire eruption. They ignored these rules. So, but anyway, Eldfjallasafn was a very interesting eruption scientifically, but actually quite small. Here's a beautiful painting, a watercolor of the Eldfjallasafn eruption by my friend Vignir Johansson. In 1963, an incredible thing happened in Iceland. A new eruption broke out on the sea floor and created a new island, the island of Surtsey. And we see that in the upper image here, on the wall here. And this eruption produced a new island, and there was an explosive eruption because the seawater was getting into the magma, causing steam explosions and gradually building up a new island. And then finally the crater got closed off from the ocean, and then lava flows started to cover the island. So it was a very instructive eruption for us, and I was very lucky because I was studying geology. I was a student then, and I was allowed to go on the island and work on it and study it with other scientists. So it was a fascinating time. But 10 years later, an eruption broke out on the island of Heimaey, very close to Surtsey. But the difference was that Heimaey was populated. There was a population of about 5,600 people in Heimaey, and immediately everyone moved off the island. Everyone moved to the mainland of Iceland to keep the people safe. The eruption broke out just at the outskirts of town. A new volcano, a fissure of several craters, and lava flow flowed out. First of all, the ash buried much of the town under ash fall, and then a big part of the town was also engulfed by the lava that destroyed further the buildings. So it was one of the more destructive eruptions in Iceland history, and it reminds us that the eruptions can take place anywhere on the land, and new volcanoes are forming all the time in Iceland. It's not just the old volcanoes that we have to worry about, but also the question is, where will a new volcano appear?